After the TSoIP transmitter receivers arrive from Sencor, I unpack them. I start with the receiver. It's a small unit that can be mounted on a DIN rail. Here you can see the connectors. This is the network connector and the ASI output. Let me put those over for the moment. Here's the TSoIP transmitter, which looks exactly like the receive unit, except that there's a ASI input and then of course the network connection. As you can see, the units are very simple. Power plugs in from their wall adapter here, but they can also be powered via the network connection with power over Ethernet. Each unit has its own LCD display that provides status of the unit. And here's the power being connected to the transmitter. Here you can see the display. It's telling us that it's not set up, that there's no ASI passing through it, and that it's using UDP port 7, and we don't know the FEC yet. At the bottom you can see the IP address and then the MAC address as it switches between the two. Here's the transmitter getting the ASI plugged into it. And now the network connection. And here is the receiver getting its network connection. It already has an ASI output connected. And here you can see its own display showing that its ASI is not being received. And it's using RTP, which is used for multimedia streams such as the TSoIP over internet. And once again you can see the bottom of the display where the IP address and then the MAC address for this device is shown. The setup used to test these products consisted of an ATSC receiver using an indoor antenna and taking its ASI transport stream out and feeding it into the ASI to TSoIP converter. Then the Cat5e cable connected to a network switch, and from there another Cat5e cable connected to the TSoIP to ASI converter. Its ASI fed into another converter to take it to USB so it could be monitored on a laptop PC. The laptop PC was running both a transport stream analyzer and an IP bandwidth monitor. The bandwidth monitor was used to measure the TSoIP stream directly from the network switch connected to the PC. And now that they're connected to a GIGI network switch, I can connect them to a computer and set them up. There's the switch, the transmitter, and the receiver. This is the setup page for the TSoIP devices. As you can see, it can be assigned a static IP or it can use DHCP. The setup is fairly straightforward, and it was quick to set it up to get a transport stream flowing over the IP network. Now that the devices have been set up, this is the transmitter showing a 19.4 megabit transport stream, and the UDP is now showing 7 and 188. The receiver also shows it's receiving a 19.4 megabit transport stream, and it's also using UDP 7 and 188. Now that the devices are running, we look back at the web interface. Here we can see the setup for the IP address, the subnet, the default gateway. Switching over to the SMPTE settings, here you can see the protocol has been set to UDP and the number of transport packets, TP, per IP, internet packet. Here it is set to 7. And then the size of the transport packet is selected as 188, which is the standard for ATSC ASI. Switching over to the TSoIP's receiver for its interface is just a matter of changing the IP address that we're looking at. Here you can see the receiver's settings. It's receiving an ASI bit rate of 19.392 megabits per second with a packet size of 188. The transport stream that was used to make these tests was supplied from the ASI output from a professional ATSC tuner. Using this tuner, I was able to use the transport streams from several local television stations for these tests. A stream monitor was used in order to see the amount of bandwidth used up by the TSoIP. Here you can see it comes up to just about 19.4 megabits. As a test, I unplugged the transport stream from the transmitter and watched what it did to the data rate on both the ASI receive stream and the transport stream over IP. In order to test this TSoIP system, I added network cable between the transmitter and receiver, reaching a distance of 394 feet and still receiving a good signal with no errors. 394 feet is a bit beyond what is the stated standard for Cat5e cable, which is 100 meters, or about 330 feet. During these tests, the equipment from DecTek was very easy to work with. The setup was easy, and it worked as advertised. Although this standard for TSoIP, which is actually a SMPTE standard, 2022, is not in wide use in broadcasting, cable and satellite operators have been using it for quite some time, as it's very efficient to move transport streams around. It allows engineers to combine several transport streams and transport them over a single network cable or network, thus making it much more efficient in transporting large amounts of video from point A to point B.